2.2 conditional statements. This is the largest section in the chapter and also the most important. It's something that you've used every day in your life, but you probably haven't paid special attention to it to know exactly what that means when I say conditional statement. It's also one of the most relevant things in terms of computer science and coding. Very rarely will you ever write a piece of code that doesn't include a conditional statement. And when we talk about conditional statements, we're talking about a statement that has a hypothesis and a conclusion. So a statement that is in the form, if blah, 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 then blah, blah, blah. So if the hypothesis, that's our P, then the conclusion. So if I study math, then I will get a good grade. Go ahead and label your hypothesis and conclusion. You'll see I'm going to use colors for this as well to make it easier. So we have our first statement here of I study math is going to be my hypothesis, that's my P, and I will get a good grade, which is my conclusion, so that's my Q. Notice the words themselves, if and then, are not part of your hypothesis and conclusion. So it's literally if P, then Q. So if I study math, then I'll get a good grade. Go ahead, pause the video, and do B through E. All right, when we look at B, if it is raining, then Mike will get wet. So my hypothesis is going to be it is raining. That comes after the if statement. My conclusion will be Mike will get wet. So if it's raining, that's my hypothesis. My conclusion, Mike will get wet. For C, we have Sean goes to school and he woke up early for our hypothesis and a conclusion. And D and E are a little bit tougher. So Patty breaks bread if she has eggs. You know very well in the English language, sentence structure can vary, right? So it doesn't always have to be if blah, 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 then blah, 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 written out in words. You can change the sentence around. So if we turn sentence D into a if blah, 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 then blah, 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 it's going to turn into if she had eggs, then Patty's going to bake bread. So notice it's not always going to be the first half of the sentence and the second half. You really have to pay attention to really where is the if then. It wouldn't make sense to say if Patty breaks bread, then she has eggs and whatnot. So last one, Mario will jump off if there's a Koopa. So my hypothesis here is if there is a Koopa, then Mario will jump. All right, number 2. Go ahead and create your own conditional if you want. Go ahead and share it with somebody as well. I'm going to move on to number 3, though. We want to change the following statements into a conditional statement. So just like the last one about Mario, it wasn't written in the correct form. So I want to write a dice roll can be a 5 into an if-then statement. So how I'm going to do that is if a dice is rolled, then the dice could be a 5. So notice I have my hypothesis and my conclusion. Once again, I am color coding this. So my P, my if a dice is rolled, then my Q, my conclusion, the dice could be a 5. Go ahead and try B and C on your own. Pause the video. All right, so here we have a triangle has 3 sides. So if a shape is a triangle, then the shape has 3 sides. And C, if a student is bored, then the student won't pay attention. So we always want to take that if, then, and turn it into that conditional. So truth values, the only way to prove a conditional false is to have at least one counterexample where the hypothesis is true, but it leads to a false conclusion. So this is exactly what we were doing with counterexamples in 2.1. We were taking the first half of the sentence, we were saying this is true, now let's make the second half false. Remember if we said all math teachers are nerds, right? We were trying to find a math teacher and then trying to prove that not every single one is a nerd. So blank, here is my example of one that's not a nerd. So to do this, we need to make our first half of it true and then the second half false. So the question is there a way to have today be the 11th and then tomorrow to not be the 12th if we want to prove it false? So is there ever a day where today is going to be the 11th and then tomorrow is going to not be the 12th? Remember, we want the first half true, second half false. So we want that blue part to be true, our hypothesis to be true, today is the 11th, and then the conclusion to be false. And this one's going to be true, right? If today is the 11th, it doesn't matter which month, there's always going to be the 12th tomorrow. Now, there's a whole bunch of random kind of situations that we can say, right? We could start by saying, well, today isn't the 11th, today is the 24th or 25th or whatever it is. But then that's not making the hypothesis true. Remember, we always want to assume that that first part is true. Today is the 11th. And you can obviously say, oh, doomsday scenario, maybe the world's going to end today and whatnot. But those hypothetical situations aren't actual concrete facts that prove it false. So as far as we know, and as far as your whole lifetime has been, if it's been the 11th of a month, then the next day is the 12th of that month, right? All right, B, if an angle is obtuse, then the angle's measure is 100 degrees. So once again, can you ever find a way when that first half is true, so an angle is obtuse, so you have an obtuse angle, but then making the second part false, that the angle's measure is not 100 degrees. So is this going to be true or false? And if it is false, make sure to give that counterexample. And yeah, it's going to be false, right? We could say 105-degree angle. We're still keeping the hypothesis true, right? 105-degree angle is obtuse, but then the angle's measure is not 100 degrees. And you could have said anything between 91 and 180 without saying 100 there. So you could have said 120 degrees. You could have said 179 degrees if you wanted to. All right, go ahead, pause the video, try C, D, and E on your own. When you come back, we will talk about it. All right, C, if an angle measure is 100 degrees, then the angle is obtuse. So can you ever have an angle that is 100 degrees, but then is not obtuse? And yeah, this is a true statement, right? If it's a 100-degree angle, then it has to be obtuse. You're never going to have a 100-degree angle that's not classified as obtuse. So notice they don't always work forwards and backwards. All right, part D, if it is raining, then Mike will get wet. So can you think of a way that it could be raining out and Mike is not getting wet? And yeah, this is going to be false. There's a couple ways we can do that, right? We could say Mike doesn't leave his house, so he stays indoors, right? It's still going to be raining, but then he's not going to get wet. If you said something like Mike has an umbrella, that would be great. Mike has a hat or a poncho or something like that on. So then it's going to be raining, but he's still not going to get wet. And E, if a triangle has four sides, then the color of grass is purple. So true or false? This one's going to be a true statement. And I know this one is going to blow your mind just a little bit about why that's the case. But remember, the only way to prove a conditional false is to have at least one counterexample where the hypothesis is true. And if we stop there, is that hypothesis true? A triangle has four sides. And the answer to that is no, it's not true. So then this has to be a true statement in general, which I know is super confusing. But in some reality, if a triangle has four sides, then sure, the color of grass could be purple, right? Because that's not the reality we live in. So the only way to say that this is a false statement is to have blue being true and red being false. In this case, blue is not true. So then we just say that the statement is true. All right, go ahead and see if you can create conditional statements for the following guidelines. State whether the conditions are true or false, and if false, provide a counterexample. So go ahead, pause video, do this one on your own. Come back and we will continue. All right, so I do have a video.
I have one for you.
Let's play it.
No! Why is the raven at a writing desk?
Why is a raven?
I'm not talking to you.
Why not? Aren't I good enough?
You've had it before.
But you were looking at me when you said, why is a raven?
I'm asking Alice!
Why is a raven like a writing desk? You know, I'm pretty sure I can guess.
You think you know the answer?
Yes,
Then you should say what you mean.
Well, I do. At least I mean what I say. That is the same thing.
It's not the same thing at all. You might as well say I see what I eat. It's the same thing as I eat what I see. You might as well say I like what I get as I get what I like.
Or you might as well say I breathe when I sleep. It's the same thing as I sleep when I breathe.
Well, it is the same with you.
All right. So, and with that video is where we're going to conclude part 1. We'll talk about part 2 in the next video.